Next, we are going to run a couple of tools to understand more about the programs we have developed, the server and client. From now onwards, what we are going to do is we are going to behave like a detective, an investigator, if you will. We are trying to understand the program, but in a very subtle way. We are going to observe the program from outside. We don't know everything about it. We are going to collect some information about the behavior of the program, what changes it is doing to certain output of certain tools. And we are going to create our own theory. And if possible, we will try to infer certain things from the way we observe these programs. Now, let's get into it and see what we can learn.
So the first tool we are going to look is Netstat. Before running the tool, we need to start the application, both client and server. We'll put a breakpoint at some interesting positions such that we will get some good information about it. Netstat is a command which is available both in Linux and Windows, but slightly different options. So in Windows, which we are in, we'll be using the command netstat-b. And subsequently, what we're going to do is we are going to look at exactly the same information which Netstat is giving from two other tools in a slightly different way, which is TCP view and resource monitor. Both of those tools are very specific to Windows. In fact, a lot of the tools we are going to see is specific to Windows. But that's fine, because we are going to learn concepts which is same in Linux, Windows, pretty much any networking stack. So what I'm going to do here is I'm going to put breakpoint at this particular line number 9. So my connection is done, and before sending any information, any data, I'm putting a breakpoint. That's what we are going to do. In the case of server, so this is a client, we have breakpoint at line number 9. So this line will not be executed. The program will break at line number 9 after executing line number 8. Now, what we can do is we can go to the server, and server, what we can do is we can put a breakpoint on line number 9 again. So what I'm going to do is I'm going to start debugging the server. The server is waiting on accept, starting the client. So the Visual Studio Code automatically switched to server because the server breakpoint hit. Because of this, I can even execute this particular line because I can make the server wait on this particular line. So server is waiting on this particular receive call. Let's remember that line number 9, the server is executing. So server has done line number 8. The line number 8 has done. Let's remember this number 516 50016. Let's remember this number. This will come up in our investigation. These numbers will come up everywhere. We are going to see these numbers left, right, and center. So server is waiting on line number 9. Line number 9 is currently executing. It has not completed. What it is waiting for? It is waiting for data from the client. We have seen all these things. And client has not sent the data. Client has not sent the data. Server is waiting for this line number 9 to finish execution. Then only the server will get the data. So we are stopping things at this point, or freezing the program at this point, so that we can investigate a couple of things, to see a couple of things in action. So being said that, let's go to a command prompt and try netstat-b. So in the run, I'm typing command prompt or CMD. And I'm going to type the command netstat. This is the command we are interested in, -b. We don't know what this command does yet. What we want to know is that any information about our programs present in the netstat command. So I kind of purposefully didn't elevate this particular prompt just to get this error message. A requested operation requires elevation. This means that we need to run this command prompt as administrator. So we are going to do something in the operating system level, in the kernel level. We are going to perform some action to get some information about this program. In fact, all the programs in the system right now, which is doing network communication, that is what netstat does. So I'm going to do run as administrator to elevate the privileges, or sudo in Linux. Again, I'm typing the command netstat. So this is how the output of netstat looks. As you can see, there is information there already. If you remember the numbers, you might be familiar with these numbers. 65432, 50016. We have seen all these numbers before, looking familiar. We don't know from where it came though. And it has written Python here. That's another familiar thing for us. Again, there is something here, but it is in the reverse order. There are some other Pythons as well. We don't know what it is. These numbers doesn't look familiar to us. So this netstat command normally takes a lot of time and has a lot of information. What I'm going to do is I'm going to pipe that into a text file so that we can open up that text file inside Visual Studio Code, which has better text analysis features. So what I'm going to do, I'm going to pipe that into a directory. So netstat output.txt. So right now the netstat command is in progress. In the meantime, what we can do is we can look at two other tools. One from sysinternals called TCP view. TCP view is nothing but netstat on steroids. Pretty much gives a similar information, but in a much more user-friendly way. Sometimes I prefer netstat, sometimes I prefer TCP view. And the third one we are going to look is resource monitor, again Windows specific. Our netstat command has returned while we were talking, but as we planned, let's go and download TCP view. So this is the searching keyword I recommend for TCP view. Download sysinternals, or you can go to this particular link right here directly, or you can simply search for TCP view download in Google. Anyhow, you should be able to get something like this. I'm going to download TCP view. I have downloaded. I'm going to extract it. I'm going to start this particular process right here. I have extensions enabled in my Windows. That's why you are seeing all these extensions right here. So double clicking on TCP view and looking at the view of it. Pretty much similar view as netstat, but it's much more user-friendly. We have a couple of different options, filters and things like that. So feel free to click around this and get a feel of it, because we will be seeing these tools in this training further. Now let's have a quick look at our Python program. So I have sorted it with process name. Process is the program. So in our case, we have a lot of entries from Python right here. There is a bit of extra complication we are adding to the whole scenario due to Visual Studio Code, because Visual Studio Code has started debugging the whole thing. That is using TCP sockets internally. That's why you are seeing a lot of other ports. But it's very easy to focus on what is related to us and what is not related to us. So let's see that, how that can be done. So what I'm going to do is I'm going to focus on my listening port. I know exactly what is my listening port. It is 65432. That is my key. Everything else I'm going to ignore. So for that, I'm going to sort this with local port. So let's go to our port. So we have 65432. right here, 65432. There are two entries for this. It is coming from the same process ID, 20260, 20260. So what we can do is we can take a screenshot of this and keep it in something like MS Paint. So I'm going to do that. I'm going to take a print screen and going to MS Paint and going to paste it here. We got our print screen right here. The reason why we took this print screen is sometimes the information in TCP view and Netstat, all these things are very dynamic and changing. We would like to have a very static view of the things we are looking at and to learn things from it. So we don't want too much static view, changing view, because the connections are coming out and going, coming and going. So these views are being updated constantly. So that's why we took a screenshot so that this Python we are interested on this port will be there. So let's pay some attention to it. So there is this Python, this is a process ID, and there is this thing called protocol right here, TCP. So the protocol is TCP. We have some other options like UDP v6. There's a chance for TCP v6 as well, but UDP is there. But in our case, it is TCP. Have we given anywhere in the program to specify that it is TCP? We don't know yet. One entry is listen. Interesting. Why it is that? One entry is listen. The another one is established. So there is a change, two entries. Now because this is listen, there is a very good chance that this process could be our server. We don't know yet, but we are seeing listen. Who is there to listen? Only server listens. Client doesn't listen. Now coming to the IP address. So this is a familiar number to us, 127.0.0.1. That is our loopback IP address, which is there coming from our program, directly coming from our program. And this is a guy we were interested in, 65432. This is our port. This is our server listening port. Again, this is a client IP address and client port. So this client port 50016, we don't know where it is coming from. We have not seen that in our program. Somewhere else it's coming from, we don't know yet. Again, another interesting thing, there is no client port for listening entry. Basically it is listening socket. It doesn't have a client entry. Interesting. There is one more entry we have not seen yet. For that, we need to sort this column right here in the TCP view and look for this number. Let's do that and find out that entry as well. So now we are back to the live TCP view again. As you can see, things are changing in the screen every now and then. It's very dynamic, depends on the actual connection. Now what we are going to do, we saw these two guys. So we suspect that this could be server 20260, that is the process ID. So if you want, you can pay some attention to this columns right here. The first column is a process name, that is a program. In our case, it is a Python. And then the process ID. So two different Python application will have different process IDs because they are two different programs. So in this case, it is the same program. That's why we have the same process ID. Then protocol. We have seen this. In our case, it is TCP. All this red flashes you're seeing in TCP view, they are changes. Red ones are going, green ones are coming. So green ones are coming up. The red ones are dying off. The yellow ones, they change the state, all that kind of things. There is a way you can set all colors in TCP view somewhere. Doesn't matter to us much. Coming back to our original discussion. Now, what we are trying to do is, we are trying to check if there is more occurrences of 65432. As you can see, it is changing and it's very annoying. So we will take the screenshot again. What I'm going to do is I'm going to sort it with a remote port. So we have seen protocol, state, local address, local port, a remote address, and a remote port. So TCP view has some more columns here: create time, module name, send packet, receive packets, send bytes, etc. Right now this columns doesn't matter much to us, but in future, if you want, you can have a look. So what I'm going to do is I'm going to sort it with a remote port. So when I did it with a remote port, again there is a 65432 entry right here, again coming from Python. Module name is Python, the process name. There is a slight difference between module name and process name, but in our case what we have found out is that there is a third entry, and the third entry is coming from a different process altogether. It's a different application. It is 13976. It is different from what we have seen before. So let's take another screenshot of this. So this time what I'm going to do is I'm going to clip the screen so that we will just get that line, and we will paste it next to this like so, so that we have everything in nearest proximity. I'm not hiding the screen to avoid confusion because there is a lot of details and screenshots in the screen. So this is the third entry we have taken, and it has a different process ID, 13976. The previous process ID was 20260. So these are different applications, and protocol is same in all three cases. And this particular entry in the TCP view has listened here. The other two are established the status. So this is the status or the state of the socket or the connection, whatever we are going to call it. And this number is same everywhere, familiar to us. And this number we don't know where it is coming from, 50016. And if you look here carefully, so this is the local port. So local port, and this is the remote port, and this is a remote IP address as well. Sometimes it is simply called remote IP or remote address, all pretty much the same thing. But if you look carefully, this number is interchanged here. So this is the local port for this program, while that is the remote port for this program. And exactly opposite here, this is the remote port for this program, and it is the local port for this program. So this is a very interesting observation. Both the process has this particular number as port, either a remote or local. So a good assumption to make here is this could be our client. This could be our client Python application, and this is the server. There could be two hints for this argument. One hint is the server which is listening. Another hint is the server is listening on this particular number. We are passing this particular number to the socket which is listening in our code. So there is a high chance that this particular port is the local port of the server. But still we don't know from where this number is coming from. We don't know yet. So these are the observations we are going to make for the time being from TCP view.
To conclude, we have looked at TCP view and saw the output of TCP view as well as Netstat. Now let's see if we can find something interesting from the output of Netstat.